What we're gonna do is we're gonna go through the homework questions, and the homework question is gonna go through here. Let me screen share, and let me share with your iPad. Share. Okay, so.
That's I want to fail my test.
This is if you're not ready.
What test?
This is if you're ready.
The math test.
But I have to do my homework.
Look, I see the
Why didn't you just do it on time? Good question. I don't want to.
So let me see, where's the file at?
Yeah.
That's so cool.
What?
Your intro.
Oh.
Oh, I want to see the intro.
Mr. Yeb, Matt.
I'm gonna look at that.
Okay, so we're gonna start with this questions here, and this is a question. Is I'm gonna go through the whole thing with you. So I'm gonna erase that everything. So now is that always gonna be that way? Is that always gonna be? It's always gonna be this way. Usually you will go through the process, just going through all that. So let me see if I see here. So what happened is you will go through here. I'm gonna take this function. I'm gonna take the original function. I'm gonna factor out a x squared. So that's gonna be negative 2x squared plus 3. And then I'll set it equal to 0. So 0 equal to x squared, negative 2x squared plus 3. X squared equal to 0, negative 2x squared plus 3 equal to 0. X squared equal to 3 over 2. X equal to 3 over 2 plus minus. So this is the x-intercept. And this roughly, if you use calculator, is roughly square root 3 over square root 2, which is roughly plus minus 1.2.
Yeah, how do we know that?
How did you do that?
Because square root 3, I know from very old-fashioned math, is actually 1.7. And then square root of 2 is roughly 1.2.
No, I meant, how do you take the derivative? Sorry, how did you find the zeros without taking the derivative?
No, I'm looking for x-intercept here. I'm not doing the derivative. I'm not doing calculus. I'm just finding the x-intercept on original functions.
Because at the x-intercepts,
Oh, okay.
see, yeah?
Yeah.
No, I did that stuff last.
Is there gonna be roots like that on the test, like root?
No.
Estimate
Shh.
that?
All right, I cannot talk over you guys at once, but I'm just gonna go through it really fast. So we got more important thing to talk about. We don't teach new lesson. We just tell you what's on the test. So if f prime x, right? So I just take a derivative of this. So it'll be negative ax to the 3 plus 6x, and I can factor out negative 2x here. And what am I gonna get? 4x squared minus 3, right?
Yeah.
So I can set this equal to 0. So by negative 2x equal to 0, x equal to 0, 4x squared minus 3 equal to 0, x squared equal to 3 over 4, x equal to plus minus square root 3 over 4. That which just means plus minus square root 3 over 2, because it's square root 3 over square root 4, the top and bottom. And then you will get 3 critical value here. Now I will plug in the number line test. And if I do number line test, I'm going to do it between negative square root 3, 2, and I'll do 0, and then positive square root 3 over 2, and that's a negative 2x and 4x squared minus 3. Of course, I'm going to get positive here, because if I plug in negative value, negative times negative is positive, and negative here. And I plug in like something like, is it greater than square root 3 over 2? Let's say 5 is going to be positive, and 5 is going to be positive. This part is going to be negative. So I will get positive, negative, positive, negative. So it'll be increasing, decreasing, increasing, decreasing. That makes this is a max. This is a min. And this is a max.
And that's what that's used for? Just the nodes, the mins and maxes.
Yep, that's a min and max. And if I want to find out a coordinate, because I really need a coordinate to graph, right? So I plug in f of square root of 3 over 2. Why do I plug in square root of 3 over 2? Because I want to plug in original function to find out the output. So, and I'm going to go back to the original function. So it'd be negative 2 times square root of 3 over 2 to the 4th plus 3 times square root of 3 over 2. Now, on your test, you're not going to get a funky Asian number like this. You're going to get an American number where you got like 1 and 2 and 3 and whole numbers.
I love that.
So yeah, you'll help you save time.
Very American.
Very American. You're not gonna get Asian numbers. So now I'm on streaming. I'm gonna get canceled for that. So that's a square root 3 to the 4th power. That's equal to, I believe that's 9 over 16. Plus 3, and then this one is gonna be 3 over 4. So that's equal to negative 18 over 16 plus 9 over 4. I can times 4 over 4 here. That's equal to 16 over negative 18 plus 36 over 4. That's equal to 16. Wait, that's a 16.
18, right?
18, you're right. Apparently I cannot deal with Asian numbers. So it'll be 9 over. Wait, what's it gonna be?
9 over 8.
9 over 8.
9 over 8. Ooh, 9 over 8. Okay, so the 9 over 8 is nice. F of 0 is also going to be 0. That's the easiest amount to evaluate. And now negative square root 3 over 2, I will not do it again just because this is an even function. What I mean by even function is this. If I plug in negative x to this, and that's going to give you, go back to original functions, which is if I plug in negative x, that's going to give you x to the 4th. And this one's plus 3x squared. It basically just go back to before. So that makes, if I plug in negative here, guess what? My answer is going to be the same. So I don't need to do extra work. 9 over 8. No extra work. Just done.
Wouldn't square root of 3 over 2 to the 4th power be like 27 over 16?
No, square root of 3 times square root of 3 is 3. And the other square root of 3 times square root of 3 is going to be 3. Yep. Yep, 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 yep.
Yeah, because so it's times 3. Yeah.
And then I'm going to do a double prime of x. So that's equal to negative 24 x squared plus 6. And obviously we can set it equal to 0. And they actually come out pretty nice number. 1 over 4 equal to x squared. X equal to square root 1 over square root 1. So probably plus minus 1/2. I would do a number line test between negative 1/2 and 1/2. And I'll plug in negative 24 x squared plus 6. This one will end up being negative, positive, negative, so it'll be down, up, down. Does that make sense? I'll plug in 1/2 in there as well as negative 1/2. But this one I'm going to plug in the original function because we're trying to get the output. So it'll be 1/2 to the 4th plus 3 times 1/2 to the 2nd. So that's equal to negative 2 times 1 over 16 plus 3 times 1 over 4. And that's equal to negative 1 over 8 plus 3 over 4. I think that's going to give you 5 over 8. I'm not entirely sure. Yeah, I think so. F of negative 1/2 is going to be 5 over 8 as well because they're even function. That's what's the nice thing. Now, our function is going to give you negative. But, you know, those are the things. So, if an even function also have a symmetry, those of you guys go into a math competition, you have to understand even function is going to be a symmetry to y-axis. So, technically, you can draw half of the graph and just reciprocate to the other half. But in this, it's no fun to do that. But your final graph will look like this, but I'm going to redo it again. I'm going to show you how do I graph from scratch. So I'm going to figure out what are the t-chart here. And I'm going to say at negative 1.2, which is square root 3 over square root 2, it's going to give you 0, 0, 0, and 1.2, 0. This is all x-intercepts. At 0.85, which is roughly is square root of 3 over 2 negative, so it'd be roughly negative 0.85, and square root of 3 over 2 is roughly equal to 0.85 positive. That one is going to give you, I think, 9 over 8, 9, about 1.125, I think. And then I say, okay, yeah, that's done. That's the maximum. I think this is a maximum, and this is a min, according to that. Now, inflection points 1/2 and negative 1/2. So if I plug in 1/2, I got 5 over 8 and 5 over 8. So this is a point of inflections. So we're going to call it POI or IP, depends on what is it. Now I'm going to go in to graph this intense, ugly graph. But, and the scale I'm going to change from the y-axis to 1 over 8. So each one is 1 over 8. Yes.
So when you do the f double prime and then you find those values, which is the 1/2, so those 2 points are always going to be the inflection points?
Not necessary unless you have a sign change. So you have a minus sign to plus sign, there was a sign change. If you got minus minus, even though double derivative can equal to 0, does not mean they are automatic inflection point until you do a number line test to prove that there is a sign change. If the sign change, those inflection points. Okay, so that's good questions. Again, we're just going to keep on going forward. There's 3 units, there's 4 units. So each one, I'm going to go with negative 0.2. So negative 1.2 is roughly 1.2 here, and negative 1.8 is roughly here, 0.85 negative, and 0.4, so it'll be 0.85 negative, and then the green is going to be right here. So there was a 3 inflection, 3 point of x-intercept. The x-intercept and y-intercept is very important for the original graph. Now at 9 over 8, so basically just 9 unit to the top. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 happened at 0.85. So this is roughly here, and this is roughly 0.85. So it's roughly right here. And here, I'm going to join the smile faces, because if I have a max, I'm going to have a sad face. And this is a sad face. And this is a happy face if you have min.
Those are the eyes and
Yeah, that's okay. So now I'm just going to trace this line. So that's going to be increasing all the way to this, decreasing, increasing, decreasing. Now remember, I just give you a brief sketch. It doesn't have any concavity to it. I draw a straight line going through those points. So then you say, okay, but what happened at 1/2? 1/2 is roughly happen somewhere. At 1/2 is going to be 5 over 8. So we're going to join those things. We're going to draw a dotted line. So we're going to use a green dotted line. So it's really light. So like this, and like this, and like this, and like this. So basically graphs like this. Now we're gonna plug in the concavity change. So concavity change happened in here. So at 1/2 is roughly 2.5 right here, and at 5 over 8, so 5 over 8, 1, 2, 3, 4, 5, 5 over 8. So it's roughly, I'm sorry. So at 5 over 8 is roughly, it's right here. I'm going to put in the cross here. And I'm going to put in the cross here is 0.5. 5 over 8 is roughly right here. So basically it's going from here is concave down. Okay, so from here up is concave down as well. And from here is going to be concave up. So basically you're going to form a very nice looking graph like this. So yeah, you're gonna have a very, very, very good sketch.
Yeah.
Yes.
Is this like exactly what Desmos uses to plot the graphs?
No, Desmo it actually generate every single value that you can possibly think of. They use everything. But originally, they probably, I know in like back in TI-83, they use some approximation because a pixel can represent so much value back then because a pixel is much bigger. They can represent so many values because one pixel could be like a 0.2 times 0.2 or 0.1 times 0.1. So the pixel is bigger, so they go with approximation. They don't go with exact values. They use approximation to get that. But later they get more sophisticated. But Decimal has a downside too, because you graph something moving very fast, there's a rendering problem. And rendering problem doesn't occur until like major animation happen. So sometimes you can have if you graph, I saw this one cool calculus kid that he's on university, first year of calculus class, and you find out that Decimal has a problem, which is rendering. And that video was like 10 minutes long. It was amazing. The guy he can see things like 100 miles, like conceptually ahead everybody else. He basically used Decimal draw animation, the animation of I don't know what's that. I might have subscribed to him. I don't know, but I'll show you in a second. But he is pretty, like the kid is a pure genius. You can tell the way he talked to you. He's a pure genius. He has less subscriber than I do. That doesn't tell you how underrated he is. But his content, it should be like 1 million views. I was one of the people I subscribed to him. He was really good.
How can Desmos get those values without being too intensive?
They do. They have a really, I don't know. I applied for a job there. They didn't hire me. They say I was too dumb to work there. So, but yeah, it's a very, very, very smart company. And the kid, the CEO of the company, graduated from Stanford, and his project is always being says, TI-84 is too damn expensive, so he build a web base of TI-84. That's what he intend to do, but now he built a better than TI-84. So.
They should make devices.
Okay, so let's talk about what's on tomorrow's test.
Answers, hold on. Wait. I will copy my board, hold on.
Hopefully.
I this down.
What's on the test?
We don't need to use calculator until after this test. So tomorrow's test, no calculator. You are using Asian standard. Except I won't give you Asian values.
It's not the gold
Asian standard with American value, whole numbers, okay? You love whole numbers. I don't know. I should be canceled a long time ago.
Well, no, but you let us say because you're Asian.
Yeah, but at the same time, I put down like Americans. All right, so the one of the test question, you're gonna have to find the extrema within the intervals. Basically, I would do is find out the critical numbers, values, and basically f prime of x equal to 0 or f prime of x equal to undefined. I will find out those c value, where that's equal to that, and I will evaluate the critical points as well as endpoints. And I will compare using a t-chart and compare which one's higher. Whatever higher value is going to give you absolute maximum value. Whatever the lowest value is going to give you the minimum value. I hear you don't need to do number line tests because you'll be doing extra step for nothing. You just basically compare the endpoints and critical points and see what happened the output is.
So this includes
Justify?
Huh? No, you don't have to justify here.
the chart.
Yeah, the chart will give you all the informations, but you don't have to do a number line test because you just want to find out what's the highest point in the interval and lowest lowest point in the interval. You don't have to do all the work.
Do you have to do like, so for that you have to do the derivative and then like set it equal to 0?
Yeah, derivative set equal to 0, find the critical value, plug in the critical value, plug in endpoint to compare.
For C?
No, plug in the critical value, which is derivative equal to 0. Okay, then you're gonna get that.
The max or min is C, right?
Yeah, maximum value and minimum value. You not compare the x value, compare the y value, which is the output.
That's C, right?
Yep.
Do endpoints count?
Endpoint you should calculate it because endpoint could be your highest value.
Alright, so it doesn't.
So what do you mean evaluate?
Evaluate means put in original function, see what happened, right? So evaluate is plug into the original functions. Okay, so this is the first thing. The second thing is the extreme value theorem. Super easy. I might not even test it, but you will have to understand it for AP exam. Extreme value theorem is basically a function continuous. So it's a function that's continuous in A and B, then you have a maximum and minimum value. You have a maximum value and minimum value. Could be a horizontal line. You're gonna have every value is a maximum and minimum at the same time if it's a horizontal line. So you can have that, yes. But you can also have a straight line. The left endpoint is gonna be your lowest value, and your highest point is gonna be right endpoint is gonna be your highest value. So then you have absolute max and min. The two golden child theorem that besides fundamental theorem calculus, this is the two theorem they love to test, which is the second theorem is actually even worse. Is they test that every single test. It's MVT stand for MBT. So MBT is mean value theorem, and the other one's EVT extreme value theorem. IVT is called intermediate value theorem. They love test MVT and intermediate value theorem. However, I'm not going to test your intermediate value theorem because I don't see the need for this one, but you will get tested. You'd already get tested before. Rolle's value theorem required three conditions. One condition is continuous between A and B, differentiable between A and B, FB is equal to FA. If you have those three conditions, then you have F prime of C is equal to 0. And that's it, that's a result. Not F prime C equal to undefined, just F prime C equal to 0.
What is that different to? How's that different to the first thing?
To which thing?
Like the first thing.
Extreme value theorem?
Yeah, no, like the first one.
Oh, critical value?
Yeah.
Okay, so critical value, one of the things like they ask, what's the difference between rule value theorem? Rule value theorem does not apply of F prime C equal to undefined, but critical value does. So remember, critical value can be F prime of X equal to 0 or F prime of X equal to undefined, which is denominator equal to 0. But in this case, it doesn't. This one just F prime C is equal to 0. Basically, you have to have a horizontal tangent, not a vertical tangent. So that's to answer that question. Yes?
For part D of number 1, it was they compare the y value. What does that mean?
Yeah, you compare which one the output, which one's highest. The highest is going to be absolute maximum, and the lowest is going to be absolute minimum. Yes, Derek?
So if it's undefined, like what do you do with that information?
If it's undefined, then then it's probably not differentiable in this case. Now, if it's undefined here, if I just say, hey, can you find a critical value? Basically, you're looking for when derivative equal to 0 as well as derivative equal to undefined, which is denominator equal to 0. That's the only time you have to look for F prime X equal to undefined when you talk about critical value. When you talk about Rolle's value theorem, we only see if they're differentiable or not. We're not looking at anything extra. Because the first condition has to be continuous and differentiable. FB has to equal to FA. Therefore, we're not looking for not differentiable. We just look at F prime C is equal to 0, which is horizontal tangent. The other one could be a vertical tangent.
Okay.
Am I talking too fast?
No, I mean, I understand it, but like, so if you end up with undefined, then it is a critical value?
It is critical value, but it's not fulfilled in the Rolle's value theorem.
Okay.
Because Rolle's value theorem says it has to be differentiable. If it's undefined, then it's not differentiable.
Okay.
So this one has the critical value here. It has extra things undefined, where Rolle's value theorem does not. That doesn't work. Mean value theorem, basically, you got two conditions to get rid of this one. Lagrange is the mathematician. Lagrange says, well, I'm just going to tilt my head a little bit sideways. Then you have 2 points here that's not equal to each other. Then you have a slope of this point. Somehow, if it's continuous differentiable, let's just say a very simple graph go like this. You must have a C value have the same slope. And that same slope is basically just the C value. You can have map happen more than one time. You can have happen infinite amount of time between A and B, but minimum one time. But does not including endpoint though. The endpoint have the same slope, does not including that point. So don't including endpoints. Do not including endpoint. Endpoint does not count. So endpoint does not count for mean value theorem as well as Rolle's value theorem. Yes.
But, so an endpoint can be a critical point, though. Right?
No, endpoint does not count as a critical point if it's in the interval. No, because endpoint is not differentiable. The endpoint is not differentiable because we talked about it before. Endpoint is not differentiable. So if it's not differentiable, I guess it can be undefined, but that one is debatable. Don't worry about that one. They won't test that. Something that weird. No, that wasn't one of the things I want to be drawing underneath. But I would say inside of my intuitive mindset is I should not including the endpoints. Yes.
Alright, so for Rolle's theorem, you get the you take the derivative set equal to 0 if it fulfills all the terms, and then you set equal to 0, and then you just like solve for 0 or solve for x, like set the x.
Set the derivative equal to 0.
Yeah, and then.
And finding the value of C.
And then do you do the t-chart thing?
No, you don't do a t-chart. You just find out which C value equal to that. So which critical number is pretty much
So you just set the derivative equal to 0.
solve for x.
Alright, it's only gonna be one solution, or can it be multiple?
It could be multiple.
Alright.
All right. So now with that being said, how do I donate? I don't know. I haven't figured out that part yet. Trust me, I will want to charge people money for what I teach. No, I'm just kidding. My information's gonna stay not monetized.
Make this class pay to win.
Huh?
Make the class pay to win.
Okay.
Yeah. I'll pay for your.
Pay to win.
One Twitch Prime equals 5 points extra credits.
Yeah.
Okay, so
Yes, Twitch Prime stuff.
yeah, I'm gonna get Twitch Prime. Yes.
I'll sub to you for 5 points extra.
Okay. Okay, so result is f of b minus f of a over b minus a is equal to f prime of c. That's what mean value theorem says. Now, for me, I have two other ways to memorize this. The second way and third way I memorize is average rate of change, because at the same time, I know those two are equal to each other. It's called average rate of change. At the same time, I know this is called instantaneous rate of change. So I know two ways to think about this. Graphically, I think about the secant slope, which is between 2 points. Between 2 points, that's called a secant of the actual graph. It's called secant slope is equal to tangent slope. That's another way I memorize something, because I try to have a least amount of memory before I go to AP exam week, because you have all other crap that you have to remember. So I try to be very, very scaffolding for everything. And you can say, okay, that's the only thing you have to know. Now, this is going to be at least like 20 points here, and this is probably 30 points here, and this probably like 30 points here, or something like that. So by doing this, you should be enough to get 80 points of the test, and this probably have another 10 points here, and that's 90 points.
Oh, what do we call this unit?
It's a graph, just a graphing of f of x, f prime of x, and f double prime of x.
Alright, so 5.
On this one here, number 5 is basically I'll give you a f prime of x graph and ask you to find what happened with the original function. Are they increasing, decreasing, max, min, up, down, inflection point? I can ask you justification. I can ask you all the shit together. Shizzle together.
Wait, so we did report justification too?
Justification as in.
I say shift. Sue me.
Wait, what do you write for justification?
No, Mr. Gaines, I'll take all your stuff.
So is there gonna be one question of each thing?
What'd you say?
This is where I get an A. I'm gonna justify the shit out of it.
Okay, so
Yes.
how do you justify?
Oh, how do you justify? So, good question. If I see something like this, so on the homework that you have, it probably has something like f prime of x, right? And you have some type of f prime of x. And I can say this point is something like this point is a maximum in the original graph because they see from f prime of x change from positive to negative at x equal to 2. So at x equal to 2, therefore is a maximum. Therefore it's a maximum at 2. That was a really ugly handwriting, but yeah, forgive me.
Sorry, can you say what that says?
Okay, they say f prime of x changing from positive to negative at x equal to 2. Therefore, its relative maximum at x equal to 2. That's how you justify this point in the original function. It went from positive to negative. Therefore, you have a maximum in the original functions. You have a maximum in the original function. Now it's gone. So, or you can justify the inflection point. You can say double derivative of x is changing from positive to negative or negative to positive. So that's another justification. Now, I might ask you both simultaneously. I might ask you which interval is concave up and decreasing. So you had to compare two number lines, and you had to find an interval that will fit in two number lines. You had to base on the two things. I have homework question on that. Curve sketching. So this is about 35 points, and this is about 25 points or 20 points. So this is a good part to give you a passing score right here if you just earn these two things. There's two big questions that you had to go through. The second question has no calculation involved. This question has no calculation involved. You just have to tell me which value is increasing, which value is decreasing. Concave up and concave down. Now, number 8 is my favorite. It says find the equation of tangent line at inflection points. That's very easy. There was a one question just looked like that in question 3 on your concavity worksheet. So remember, question 3 in your concavity worksheet. Concavity worksheet. It has a question like that. Okay, it was a standard form. Yes.
Can you open up all the homework so we
You can open it once you submit it, and then all you got to do is click on the planner. You can open up all the old homeworks.
Okay.
What does 7 say?
Curve.
7 says number line tests to the trick onto a trick. So I might give you some function like this: f of x equal to sine of x minus square root 2 over 2x. And I say, hey, can you find me the interval is increasing or decreasing? Well, basically, I take a derivative. Sine of x becomes cosine of x. Derivative of this is equal to square root 2 over 2. Find a critical value, which is at pi over 4 and 7 pi over 4. Plug in any value there. Between 0 to pi over 4, I'll plug in pi over 6. And between pi over 4 to 7 pi over 4, I'll plug in any value between that, which is pi over 2 is good. And I'll plug in 11 pi over 6. And I'll plug in each thing's analysis on which interval is increasing, which interval is decreasing. And that is what a general view is going to be.
Okay, and what are those?
Well, Gianluca says hi.
What does that mean?
Gianluca.
So give us a trig function.
Gianluca is a
Number line test for
one of my favorite students that happened 4 years ago. He's at Caltech. He got me this flag. Gianluca, this is your flag. By the way.
John
Oh,
Luca.
what do those values say?
Huh?
What do those values say on the number line?
What's the value say on the number line? What's a pi over 4 and 7 pi over 4? Although I didn't teach him calculus though, I teach him free
Equation
calculus.
of tangent line of
Pretty clear if we have to justify something, like, what?
Yeah, I would say justify.
So yeah, what is? Can you go over 7 again?
7, it's just a number line test. So I will probably like say, I will give you a function like this, right? Y equal to, I don't know, tangent of x, I don't know, minus x, right? And I will say which part is concave up and which part is concave down, or not concave up, concave down. Which part is increasing and decreasing.
Or the I have to do the derivative.
I think it started.
Yeah, so you're gonna have secant square of x minus 1 equal to 0, secant of x equal to 1, x equal to pi, I believe. No, actually, it's 0 to 2 pi. So that was a horrible question. That's a horrible question. Maybe f of x is equal to cosine of x. I'll just use the question I have. And then if I take a derivative of this, it's going to be what? Sine of x minus square root of 2 over 2, right? So, negative sine, yep. And then I will test, that's going to be negative square root of 2 over 2, so it'll be at, I believe, where's the negative square root of 2 over 2?
That's at here. I got you. That's at 5 pi over 4 and 3 pi. No.
5 pi over 4 and where?
7 pi over 4.
7 pi over 4, thank you. And then just test the value here and see if they are positive or negative. More likely, yeah.
How many questions are gonna be? Like out of those 8, is it gonna be like 1 or 2 questions of each?
The main question is going to happen in those two. And the other question is going to be a small question.
Is it justify for 7?
Justify for, you don't need a you don't need a justify. No, justify is for 5.
Just say when it's increasing or decreasing.
Yeah,
What intervals? Alright.
So it's 100 points, right?
100 points, yeah.
That's all.
And then
A lot of
we're gonna be
points.
tested like on the Rolls theorem and the mean theorem, so we're gonna have to like write it down.
No, you won't ask you to write down. You will ask you to verify or are they approve or not approve. So why? So for example, like if I have a function like 1 over x plus 2 like this, between let's say negative 5 to 5, then you're gonna say the mean value theorem does not work because x equal to negative 2 is not continuous.
AJ.
So yeah.
And do we do like, no, that actually works.
And that's it. Or like it could be absolute value x plus 2. You're gonna say x equal to negative 2 is not differentiable.
Let's see. Yeah. What about 8? Can you give me like an example of what that would be?
I did have example here on the homework. I posted.
The
I
homework
posted
is-
homework.
Do you know what question it is?
It's on there. Look it up.
So like from the problem from the weekend, we're gonna have a problem like that on the test or something.
Yeah, you're gonna have one question on that that's about 20 points. It's much easier, easy number to work with. You don't have to worry about something about fraction. Everything is gonna be integer. It's very easy to
Can you
sketch.
solve for x and then like use that value?
Oh,
You
we have
plug,
to
you
do
plug
derivative
in,
tests?
alright, you plug in
Huh?
the x right
We have to
here.
do first and
You
second
found
derivative
x,
test?
is one
Second
third.
derivative test.
So you plug in
Only.
the x to the.
First derivative test, you did it on sketch and graph. But second derivative test is the Karate Kid of the things.
To find.
It's where you
y.
like, you plug in all the values of the
Now you
critical
have the y,
points,
now you can.
and then you,
And the
and so you plug, sorry, you plug in all the values where f double prime is equal to 0, right? And you see
F single prime equal to 0.
f single prime is equal to 0.
And then you take the critical value, plug in the second derivative. And you see they are positive. If they are positive, it's concave up. So it's a max. If they are concave down, then it's going to be... Concave down is max. Concave up is a min, sorry.
And what happens if it's what? How does it fail though?
Huh?
How does it fail though?
Fail if they equal to 0. Because you plug in second derivative, you get 0. So one of the example there, you're gonna get a 0.
And now we have Will Robinson. Oh my god.
Oh, that's gotta be.
And Jake.
And Jake.
And Andrew Green. Andrew Green.
Bro, how does
Tell
this
them how
guy survive that failure?
Mr. J.
Any practice problems on the one with like, the semicircles?
Yeah, I think I just write down this morning.
Yeah, it was the square root of 49 minus x squared.
Yeah. So for Calc 2, I can write a couple questions. It doesn't hurt for me to cut what questions. So,
Trevor, are we going down there to tell them that it's pending, or do we?
so I can ask you a geometric way, right? So geometric integral. So I can ask you that says integral of square root of 25 minus x squared dx, and between 0 to 5. I can ask you between -7 to 7, a square root 49 minus x squared. Basically, one is quarter circle, one is the half circle.